now we'll be learning about new Cartesian sign convention. What is new Cartesian sign convention? Yes, I will tell you. In spherical mirror, we have to follow some signs convention. That sign convention is called new Cartesian sign convention. What we should follow every time, first point for new Cartesian sign convention, first property is every time the object should be at left side. Every time the object should be at left side. This is the first property for new Cartesian sign convention. Then second point, all distance parallel to principal axis are measured from the pole P. The things, the images, reflection, everything parallel to principal axis is measured from pole P. It is P the measurement point. All the distance measured to the right of the origin along plus axis. The right side of origin, all measurements are done on the plus. The reflection which goes to right side is every time plus, and the reflection which is followed from the left side goes to left side is every time minus, means negative. Fourth point, the distance measured perpendicularly to and above the principal axis is plus y-axis and taken as positive, which are the distance parallel to y-axis is every time plus. It means that from this side all the measurement is plus, and from this side all the measurements are minus. This is positive sign, and from this side of pole everything is negative. This is main property of new Cartesian sign convention. Now we will be learning the formula of new Cartesian sign convention. First is new Cartesian sign convention. We will see the direction of incident light. This is our direction of incident light, and this is our the distance towards the left side, that is negative. So formula is 1 upon V. V stands for distance of image. Distance from image from pole, it is 1 upon V, plus U stands for distance from pole from reflection. This is incident ray, and this is reflection ray, that is negative, and equals to distance of focus point 1 upon F. V is distance of image. The reflection which is drawn is from pole to mirror is V, and U is distance of object from pole. The real object from pole, distance of that object from pole is U, and distance of image, the reflected image, is V, and F is for focus length. Mirror formula. First we learn about convention sign formula, and now it is mirror formula. 1 upon volume plus 1 upon U, that is object, is equal to 1 upon F. Now second topic is magnification of spherical mirror. What is magnification of spherical mirror? It is the ratio of the height of image to the height of object. The image which is creating that, it's the image height and the height of object is magnificence. So formula for magnificence, M stands for magnificence, height of image upon height of object. That is, height of image is shown as h dash and height of object is shown as h. This is our first equation. Then what is magnificent? First of all we learned about magnificent, height of image and height of object. Now we learn about distance of image and distance of object is minus 1, negative V upon U. That is our second equation. So first equation and second equation we had created the entire equation form for magnificence is equal to minus volume of image to distance of object is equal to height of image dash to height of object. This is your magnificent formula. Learn about reflection of light. As light has two types, reflection and refraction. So our first reflection is completed. Now second part of the lesson is refraction of light. Light seems to travel along straight line. Yes, we learned light always travel in straight line in a transparent medium, that is electroefficient waves. What happens when light enters from one transparent medium to another? Yes, when surface is transparent, what happens? The image is virtual, which is created beyond the surface. You might have observed that the bottom of the tank or a pond containing water appears to be raised. Similarly, when a thick glass slab is placed over some printed matter, the latter appears raised. Why? It is refraction of light, which is done. The light passes through a transparent object with a large amount. We can see the large sign of that same words written on that paper. Now we will see refraction activity. Take a bowl of glass, place a coin at the bottom of bucket, take a coin and put it in the bucket and fill the bucket as much as you can. As you are pouring the water, the size of the coin gets big. It gets big. Why? This is refraction, because water has transparency. So the image get transparent and we get bigger image. As we see image, by pouring the water in the bucket or in the glass, the image gets large and we see big image. It means as the transparency increases, the refraction of image gets big. Second part of refraction through a rectangular glass slab. Now next exercise is refraction of a rectangular glass. Fix a sheet of white paper on a drawing board. Using drawing pins, place a rectangular glass slab over the sheet in the middle. Draw the outline of the slab with a pencil. Let us name the outline ABCD. Take 4 identical pins. Fix 2 pins, say E and F vertically. You can see the image. This is EF. This is our worksheet. White. We took A, B, C, D and glass slab in the middle we kept. And this is our EF pin. And this is the second pin which we took. That is G and H. See the rectangle, the line which is refracted from the transparent move. When we remove the pins, a reflection line virtual image created. The line won't be straight as we had kept it like very unconditional only. E and F and G and H. But the image created is virtual. And thus proper image won't be such type. The direction of reflection goes from up to down. Laws of refraction light. First, the incident ray and the refracted ray, the normal interface ray, two transparent medium at the point of incidence. All these points lie on the same plane. The ratio of sine of angle of incident to the sine of angle of refraction is constant for the light of a given color and the given pair of media. This law is known as Snell's law of refraction. This is true for angle 0, I and 90 degree. If I is the angle of incident and R is the angle of refraction, then sin I upon sin R is equal to constant. Every time the incidental ray and refraction ray is constant. Means same, it is vice versa. In concave and convex means reflection images, the I and R is equal, and in refraction I and R is constant.